All right, lesson 7.4 is actually inverse functions. Now, before we start off, basically the only thing that an inverse function is, if this was my function right here, -2, 4, -1, 2, 0, 0, and 1, -2, only thing an inverse function does is it switches your domain and your range. So in other words, my 4 is going to become my x value, my -2 is going to become my y value. So this is 2, -1, the 0 switch, and -2, +1. Okay? So those are the only things that an inverse function is. Okay? So if I actually gave you a function, gave you an equation, and I said I want you to find the equation for the inverse of the relation y equals 2x minus 4. Well, there's three basically steps. So we're going to rewrite the original equation, y equals 2x minus 4. And then we need to switch the x and the y. So the y becomes the x becomes the y minus 4. And then we just solve it for y, like we've been doing all year long so far. So we're going to add 4 first. So I get x plus 4 equals 2y, and then divide by 2. Okay? So y equals, remember there's an invisible 1 here, so 1/2 x plus 4 divided by 2 gives me 2. Okay? And that's all there is to finding the inverse. Okay? So go ahead and, on the next example, let's make this a U try. So go ahead and pause the video. And I want you to find the equation for the inverse of the relation y equals -3x plus 6. All right, so let's go ahead and do this. So remember, the first step is, let's just go ahead and rewrite our equation. Y equals -3x plus 6. Next step is we have to switch our x and the y. So x equals -3y plus 6. And we're going to solve this thing for y. So we're going to subtract 6. So x minus 6 equals -3y, and then divide by -3. Okay. So remember there's a invisible 1 here. So I get -1/3 x. -6 divided by -3 gives me a +2. And that equals y. Okay. Now one thing that you need to keep in mind, and this is something that I would highlight, make sure that you know, this is an area that a lot of students will have trouble with. A lot of times, if I give you the function f of x, one way that we're going to refer to finding the inverse is if you see f with a -1 on it. Looks like an exponent. And all this means is the inverse of f of x. Oops. This just means the inverse of f of x. Okay? That's all that refers to. Okay? All right. So, next example I wanted to know is you needed to verify that f of x, which remember is just y equals 2x minus 4. It's just another notation. And the inverse of x, because there's the -1, is 1/2 x plus 2. And we want to verify that they're actually inverses of each other. So the way that we do this is, if we take f of f to the -1 x, okay, just like we did in the last lesson, in lesson 7.3, and we actually, our result is x, and then we do the opposite where we take f of -1, or the inverse of x, of f of x, and we find that, and that one equals x, then they're going to be inverses of each other. So let's go ahead and do this. So f of -1 is going to give us 1/2 x plus 2. Okay? So now f is 2x minus 4, so everywhere I see an x, I'm going to replace it with a 1/2 x plus 2. So I get 2, and remember my x gets replaced with 1/2 x plus 2 minus 4. So 2 times 1/2 gives me x. 2 times 2 gives me 4. minus 4. So positive 4 minus 4 cancels out, and I'm left with x. So this side checks out. So then I need to do this side. So remember, f of x is 2x minus 4. So I'm going to do f of negative 1, 2x minus 4. Okay? So f of negative 1 now is 1/2, and I'm replacing my x with, remember, 2x minus 4 plus 2. So 1/2 times 2 again is x. 1/2 times negative 4 gives me a negative 2 plus 2. So negative 2 plus 2 gives me x. So this side checks out as well. Okay? All right. Now, we can still do this with radicals or rational expressions. And I just want to know that these two functions are actually inverses of each other. Okay? So remember, all we have to do is, we're just going to do f of g of x, and we have to verify g of f of x. Okay? So we're just going to replace each of those and see if we end up, the end result is an x. Okay? If one of them is not x as the final product, then they're not inverses of each other. So let's check this one. So remember, g of x is just the square root of x, and f of x is x squared. So we're going to replace the x with x squared. So remember, anytime you square a square root, they cancel out, and my end result is an x. So this side checks out. Actually, let's go ahead. This one should have been, this one we just did the g of f of x. My apologies. All right, so let's fix this one. So we actually get, let's erase this. So remember, and that was okay that we did this. This was, remember, we have great moments. But since we did g of f of x, now we need to do f of g of x. Okay? We just did that one. Yeah, that was right. My apologies. That was correct. All right. So we were on the right track. All right. So this was f of g of x. Okay. Now we are going to have to do g of f of x. So f of x is x squared. And I'm going to replace all my x's in my g function, which is the square root of x, but my x gets replaced with the square. So it doesn't matter if it's written like this. Doesn't matter if the square is inside. The square and the square root are still going to cancel each other out, and I'm left with that x. Okay? So it does check out and verify.